So the universal timer is the second project utilizing the versatile 555 timer. Now first off, this circuit has had a few changes made to it from the original project in Funway into Electronics Volume 2. One of the obvious changes is the soft on-off, which was introduced back in the LED flasher. But another change is I've replaced the electromechanical relay with this pair of MOSFETs and these driving transistors. So when the circuit is powered off, both MOSFETs are in the normally open state. Once power is applied, this MOSFET here becomes the normally closed side of the relay. Now, I know that I can replace that with a depletion mode MOSFET, which will leave it in normally open without any power on, but I am still not entirely comfortable with the biasing of a depletion mode MOSFET. I am still learning it. Once I figured out what changes I needed to make, I will make those changes and I'll revisit the project with that change made. The reasoning why I decided to update the circuit design is because I thought, being the modern era, a lot of stuff is solid state, no moving parts. Yes, using a relay would be the simpler option, but that does involve dealing with electromagnetic coil, and I thought, could I not improve the circuit so it was solid state, no moving parts, and be more modern and be more power efficient? And of course, yes I have, and this is what I've done. So instead of the pin 3 on the 555 timer driving a electromagnetic coil, which then requires a reverse biasing diode to prevent backfeed of voltage current, we are instead driving the bases of two transistors. In this case, just a basic BC848 transistor. The through-hole version would be a BC548. These provide the necessary driving voltage to the gates of the MOSFETs to put them in their appropriate states, whether they're in normally open, normally closed, and they change state accordingly. So with that part out the way, let's get back on to the description of the actual circuit itself. This is the purpose of the universal timer. So the circuit is similar to the doorbell project. It utilizes the 555 timer. However, in this application, the circuit is operating as a one-shot timer and not oscillating, so it will only operate for a period of time once the button's been pushed. The 555 timer works by sensing voltage levels and acting when certain levels are reached. These levels are called threshold voltages, and the different pins sense different thresholds. For example, if the voltage at pin 2, which is the trigger, falls below 1/3 of the supply voltage, the IC turns on. It doesn't matter if the voltage rises again or falls again. Once the threshold is reached and the IC turns on, pin 2 is virtually disconnected within the chip itself. Conversely, if the voltage at pin 6, the threshold pin, rises above 2/3 of the supply voltage, the IC will turn off. Once again, this pin does not have any further function until the IC is turned back on again. We make use of both of these thresholds in this circuit. As you can see, pin 2 is normally held at positive high by R1. When the push button over here is pressed, pin 2 is taken down to the negative supply, obviously passing its threshold on the way. The 555 timer then turns on. Current flows from pin 3, which supplies a current to the base of the two transistors, activating the MOSFETs. So until the IC was turned on, pin 7 here was connected to the negative supply via the internal circuitry in the IC itself. Once it conducts, the connection is removed. So then D1, D2, R3 and VR1 along with Q1, which is a PNP BC848 transistor, form what's known as a constant current source. A known and very stable amounts of current is able to flow through Q1 and charge C2 and C3 here. Being in parallel, they are effectively one capacitor. As C2 and C3 charge, the voltage across them rises. After a time, this voltage reaches the pin 6 threshold and the IC and the 555 timer turns off. Pin 3 stops supplying current, obviously in this case to the transistors, and the MOSFETs then return to their original state. So it's an incredibly simple circuit. This circuit allows for the timing of a number of things. In this state, it can be used from anywhere from about 1 to 5 minutes, and that would serve, in things like that. If you want something that had, say, less time, you want to change the value on R3. So if R3 was changed from a 47K to a 4.7K resistor, instead of having an upper value of say 4 or 5 minutes, you would have about 5, maybe no more than 5 or 6 seconds. So the amount of time available on the pot's actual time adjustment that's set by VR1 becomes substantially less. So R3 actually sets your maximum allowed timing value based on how much time you require. So 47K is more along the lines of 5 minutes, whereas 4.7 will be more along the lines of 5 seconds. And any values in between will set that upper value of the circuit. But for now, we're going to build the circuit just with the 47K and adjust it to see if we can get a 1 minute output from the relay. And I'd like to take this time now to thank the good folks at PCBWay. They are sponsoring this educational series as we learn the fun way to do electronics with surface mount components. PCBWay can provide you with high quality PCB manufacturing services, and they even have a library where you find shared projects. Now, this shared project library is where you'll actually find these find SME projects available for purchase from PCBWay. They will generally provide you with the boards, and there's also information there where to get the various components. Now, I primarily use element 14 for that, and that's generally where I would order most of the components from. But for every purchase you make, if you use the discount link from this video, you will get $5 off on your first purchase. Plus, with each one of these Funway and SME projects that get bought, a small portion comes to me that help these videos to be made and help support me in making this content. So here's the PCB in KiCad for the universal timer. So you can see stereo show is right here, 555 timer. We've got our diodes, resistor and transistor along with the variable resistor forming our constant current source, which sets our time period as to how long the timer is engaged for. And then of course we've got our output circuitry here, which provides the switching output required to switch whatever load it's doing. Now in general, I wouldn't switch anything higher than a 3 amp load with this. I haven't designed for anything, I haven't really designed to take any higher, so I wouldn't recommend you going any higher than 3 amps. And of course over here in this section here, we've got the soft on off, which is people familiar with from the LED flasher. In this case, instead of having a membrane button, you've got a push button you can wire in because of the way this board will be mounted in its housing. So it's a fairly simple circuit, fairly simple to use. We're using a through-hole LED to indicate when it's on or off, and I will show when I go to build it as how that would function. But apart from that, it's relatively easy. Again, we're using the 1220 coin cell batteries to power it, so 9 volts from 3 coin cell batteries, as we did with the Ding Dong doorbell, and we've also done with the LED flasher. In the next circuit though, we're only going to be using still 3 batteries. The next one will be the Morse code trainer. So please like, share, subscribe, and I'll see you in the next video. Bye for now.